All right. Hi, everyone. Okay, we're gonna jump right into Stable Diffusion using ControlNET and the various options you have of using these tools. So in all cases, we're gonna be using the automatic 1111 web UI. It's super simple to use, and I'm gonna give you some options on how to use it, how to get all the models loaded. The main benefit is its versatility and changing parameters and uploading different models, Lora models, and having access to ControlNET down here below. I noticed some of you have had an interest in downloading this locally. To do that, GitHub automatic 1111. I shared a YouTube video with information on how to do this, and right at the bottom here, there's kind of that to-do list and running all these steps. If you have Windows, there's a Linux, and there's an Apple version as well. The one key thing, I won't go into this, it's for the people who are downloading it locally, which gives you more speed and reliability so you don't have that runtime issue with Google Colab, is that the models that we're going to use in Colab, you have to save in Stable-diffusion-webui models, Stable Diffusion, and you just add them here. Okay, so next up is installing this on Google Colab. So I am saving two main options. I'm going to go over two main options. The first is the one we went into class. The second, which I'll show just right at the end. If this doesn't end up working for you, feel free to use that second link, and it's an easy, also should be a click and run. The bottom line in all of this is that we're not always sure when we run a Google Colab what GPUs we get. The code can sometimes change. The installation packages in Google Colab it varies. So there is a maintenance side that always happens when running these notebooks. The bottom line is that I would strongly encourage all of you to get the Google Colab Pro account. It's just $10 a month, and we'll be covering lots of these notebooks throughout the term. So that will help and be a great resource to run things faster, more reliably, less of those runtime prompts, and better image generations. Okay, so the link that I sent you guys, it's in our resources. It's the very first one. We will now use the second link here, which is exactly the same. And the location to find it, if you're looking for it, is either in the Sheets file, or if you go on the same file we ran last time, right at the top here, there's that link, GitHub Fast Stable Diffusion. And right here, where is it? Google Colab, Automatic 1111, and you can just click on that. This is essentially the same thing. The only difference is that I added some extra models and made some very small changes, but the underlying architecture is all the same. So I'm going to run this. I've already been running all of the cells, and so a quick recap within that process is to set up your Google Drive and just simply run all of the cells. Now, before doing that, I just want to make sure that if you have the Pro version, that you're maximizing your resources. And so you can go and change runtime type. And if you can, try to run the A100 GPU. And like sometimes it works, it's one of the highest GPUs available, but likely it'll end up giving you a V100. The free version runs with a T4. So that's before running any of the cells. Go on runtime, change runtime type, and get that running. Cool. So as for all collabs, I advise you to save a copy in Drive. In this case, for the tutorial, you can just run it, and there's no issues with that. Even if you upload your own Google Drive, no one will have access to the information. So instead of clicking runtime run all, which we discussed in class, I would like you to run it to requirements, because in this case here, we don't have access to all the models that I shared with you. So I'm going to make available this doc here with all of the links and helpful things that you might need. Now, right at the bottom, and I'll share this below, is the link of the two models that generate high quality images. Again, that will be on CVTI, and it's called Realistivc XL. So quality is pretty good, generally trained on portraits. And let's see, the other one is Realistic Vision, and that's the data sheet, and similar quality, pretty high resolution. So I'll leave it up to you guys to choose which model works best for your prompts. You can also go back on the home page here and type in like architecture or realistic or whatnot and download right here, or copy, let's say, copy the link essentially. Where is it? Yeah, you're essentially, oh, here we go. You're copying that link address for the safetensor file. So you can just use these two. These are really great models that I've tested before, and I'm gonna share below the links for them. So you see like Vision XL V3 pre-trained model, and you can copy that and put it into model link, run the cell, and then before running the Lora cell, you can do the same, copy this link, pre-trained model link, and then paste it in. Now at any point, pause the video, see what I'm, find the exact links, paste it in, and then start it again. The setup is important just to have everything and some options when you're there. Okay, the Lora model will help increase the quality. So here there's a CVTI Lora model link, and that's actually, oh no, these are for the models in general. The link, that's gonna be the link. So this will give you that file directly. Okay, so this you would paste in, and then for Canny, right here, once you run the Lora cell, you can go on show code. The only thing to change here, and you see I have Canny full. On yours it should say mid or halfway, or like, just change these two, change the value here to full. That will give you access to a better ControlNET model. And again, to find that, you're clicking on the show code button, and you can just change manually. I think it's usually on mid. You can change it to full, and this one as well. So that's the Canny preprocessor and the depth preprocessor. Great. So run that, click on Canny, run play, run the cell, and then click on depth, and then run the cell. Again, those are for the XL models. If we do end up using some other models, run the same on the V1 models. So you can run Canny, and then you can run depth. That's pretty much all you'll need. So you might have to run this 4 times, and that gives you better availability. Okay, if you then click the final cell, you'll start Stable Diffusion, you'll run everything, and hopefully it'll all work. I realize some of you have been running the free version without the Pro Google Stable Diffusion, the Google Notebook. And this seems to be the error right here, file not found, no checkpoints were found. Now, long story short, a way to troubleshoot if this ever happened in future, and generally speaking, In GitHub, there's always an Issues tab. If someone posts some code, you can go on Issues and then simply paste in your problem. And it's likely someone has that same problem. This is posted on December 14th. So quite not too long ago, where many people had this similar issues, and oftentimes when you see ticks or smiley faces, it means that it worked for some people. So we took this code, which is going to be in the notes. If this isn't working for you, obviously if all the cells run for you, or if you're using the pro version, it should run fine. If you have an issue, you can add a code cell right here, paste that code in, which is in our notes, run that cell, and then run the final cell. For me, that worked. I mean, both versions worked, and I tested it with the university email as well. Okay, then you should get that link. This will be right at the top, right at the top of your code, so right here. And you can click, you can run that. And this should bring you to the user interface. Okay, so checkpoint. Open the user interface, see all the models that we've downloaded, and test it with a house prompt. I'm going to go into the one that I already have open right here, and timber house. I'm testing the realistic vision model, and the only change which is evident here from what you will see is that I've changed the image width and height. So these models have been trained on 1024, so it's always better to keep that same dimension, and you can get some great qualities from that. So the next, just to kind of cover some parameters from top to bottom, the first one is that we're on text to image for now. These are some prompts which you can test out, which the models in the pre-trained model datasheet, often there are some suggestions of what prompts work well with the models. So feel free to, actually it's in the other one. So back to the datasheet in V6, I'm gonna just scroll down and prompt. I use these prompts to get good results, and you can copy that. I have added both of these at the bottom. These are sample prompts. Feel free to use them. I encourage you to try your own, test things out. The main thing is the prompt. The negative prompt is more to tell it what not to do, but experimenting and testing these out is always part of the process. Okay, so that's the very first step. Where are we? Putting the prompt in, iterating over that. The second step is controlling the number of steps. I like to keep it between 20 and 50 steps. The more steps you do, the less grainy the image and the more the image diffuses, so the quality usually increases. The model one dimension should always be 1024. Always maximize that dimension as much as possible, stopping at 1024. You can make more images, kind of make a grid or whatnot. The CFG scales tells the model essentially make this image less similar or more similar to my prompt. And 7 is a good balance, but I would always keep that as a fixed figure. The seed value essentially tells you what type of image. I could type in like 1,000 and it'll generate a different image. If I want to go back to this and generate a similar image with the same prompts, you would have to tell it what seed to use. So already if I change that seed, I change it by 1, it's exploring the solution space and finding, generating another value. So 10,001 will be different from 10,000. The standard is to keep it at -1, that essentially means it will randomize those values. It's loading. Okay, so there are your images. This is the text-to-image process. If you ever wanted to see where these images go, this is the file path. It's typically saving it in your drive, a file called SD for Stable Diffusion, and you can just follow these steps. So outputs, in this case, it's text to image, today's date, and you should be able to see all of the images as they load. That was a mistake. That was using the negative prompt as a prompt. But you can see they load one by one. Great. And feel free to try these other models. So always explore Civitai or just test out the other one that you've downloaded. Okay, main part of this tutorial is let me just check something, making sure ControlNET works and trying to test it out with your images. Okay, so the second tab is image to image. Same process, but we're adding the text prompt with an image prompt to condition that output. Same prompts, I added my own, so realistic photograph of a timber building, Antonio Gaudí style, vernacular, and so on. My image here is a Zaha Hadid building, which I want to change, but I want to keep some of these edges. The question is, how do we retain that edge information? Here we keep those same parameters, so I'm making sure one dimension keeps to the 1024. And here you can see when I change the width, or the height in this case, I'm making sure that this red box is telling the model what my proportions are to generate a new image on. So it's always good. You can change it, in this case, intentionally, and squish the image to generate different outputs. But if you want to keep coherence between the input and the output, it's always good for you to make sure that red boundary, where is it? 1024, here we go. That's about right. So you see, I got the proportion wrong in that one. I click generate, and it squished it, which is not always a bad thing. It could be intentional if that's what you like. I am going to test out the turbo model just to give you a quick comparison. We're using ControlNET, and I'm going to show you how to use that, but just to show you how these can vary. If you want to see if things are working, hopefully your runtime doesn't reset too often. It does happen when you're on the free version, but you can always go back to Google Colab and just see if things are running. And so here you see that percentage, and it's showing here as well. So you can see there's this odd difference between the two images. So what's great about this tool is that you can actually control how different or similar those images are. And the main difference in parameters is this tab here called denoising strength. Denoising strength essentially tells you how much diffusion happens. And what that means is that if I put the denoising strength at 0.1, let me just put this a bit faster, 20 steps. That means that it's going to denoise it a very little amount. So it keeps, for example, it keeps that coherence quite a lot. It changes only that 10% of final diffusion of the image, which isn't, you see that there are differences with the image. If I did the opposite and put it at 0.9, for example, and ran the same process, then it will diffuse a lot, so 90%. So things will look very different. So where we want to go is kind of that middle ground, maybe 0.6, and this will really change according to every image that you generate. So feel free to always, every image will be different in terms of how much similarity you would generate. Maybe it needs to be 4 or 5. Let's try again. It's an iterative process again. So that's looking more like it. I like how there's some differences to it. And you can start seeing those timber, that vernacular, a bit of Gaudi there. We could add to the prompt to change the foreground to maybe say a marble public square. Let's see if that works in the next model. Okay. You're going to see ControlNET right here. Now, for demonstration, I'm running 2 units here. So I'm running the Canny and the depth. For now, let's just start from where you would start. To get ControlNET to work, the very first thing is to click on Enable. The second step right here is to tell it what control type do we want. Let's use the depth for now as the first go. And you can choose, for example, to use different types of depth map models. The preprocessor, essentially it generates a depth map or the edges of that original image. And then the model that it uses is a XL depth map model. And I'm going to increase the resolution to 1024. And if you want to try, my prompt is more important, ControlNET is more important, you can test and see how those outputs are. While it loads, the one thing that I have added, you might not have this just yet, is that Lora model. The Lora model you can see in these tabs here. If you click on it, I'll remove it. If I click on it, it'll show that prompt right there. So it will add that extra level of detail present within that pre-trained Lora model. It's like another addition in quality. And that should have run if you downloaded that link right there. All right, so the marble clearly affected the whole building, but you can see that coherence in all of those edges. And so let's see if we increase that strength diffusion, things might actually 0.5. I can interrupt it. Let's see if it interrupts and regenerate. Well, you can see here it's always generating those 2 images. The first one is that preprocessor, so that in this case we chose depth, and the second one is that image. So it's not actually using this whole image, it's using this as the base point and then generating this image from that. Okay, so why don't we try Canny, for example? Canny, we can use this Canny preprocessor. In this case, I have full because I added that full in the code and downloaded that model. I'm going to increase the preprocessor resolution to 1024 and rerun it. Always remember we need to try out these denoising strength and change it accordingly. Let's see what happens. It's taking a little bit because it's using a new model, and you can kind of see here that it's running the Canny model. It got that resolution, and now it should have generated it 90%. Here we go. So this is the Canny edge model. So it took all of these edges and it's trying to the best it can to match those lines. So the better your input image, the better these edges will be. And this is an example of those outputs. You can see the windows are a bit confusing for the model, so it does struggle a bit within that fine grained detail. but there are ways of fixing that or affecting that strength again. Okay, the final thing is that if you wanted to, for example, add 2 models just to increase the quality, for example, or test them out, there's no magic formula. But what you can do is, for example, say, I want to do 60% ControlNET for the depth. In this case, I had it 0.7, but I meant to keep it at 1. But you could change that, for example, to 0.7 or so. So you balance how much it uses each of those models. And you can go on if you wanted to. You could add multiple preprocessors, and there are many other ones that you can test. So segmentation, Scribble is for drawings, line art, MLSD, and I added a resource right here in our notes, ControlNET information. This is a Stable Diffusion art guide. So if you wanted to read a little more about each model, let's see if it's frozen. You can just see line art. MLSD also takes those lines. This is normal Midas. There are different Midas models. Scribble takes those edges. Each one is better for some things and worse for others. But I always use ControlNET. I always use Canny edges or depth as my main model, let's say. All right. So that's an example, and you can test this out with different inputs. You could, for example, take that sketch that we used. Let's see, maybe the tower model. Let's see, this might be too faint for it. We would probably have to timber office building. That works. In this case, we would change the proportion and make the long edge 1024. The short edge would be about that. And we don't need depth in this case because it's a line drawing. And so we could use just Canny for now. Let's do a quick test and see how it could work with a sketch, for example. The same works with the Rhino model and other different inputs. It could be a origami, it could be an image, it could be a sketch or an assembly of different objects. So feel free to try different things out. Oh, I think I got my proportions slightly off. And one thing you can test, since this is already a sketch, we could avoid adding the preprocessor in this case. So you could possibly remove that if it's already in this format as lines. I think the edges are maybe not as clear. So, and the proportions here are not, I messed that up. Should be about that. I squished it all. And in this case, maybe let's add some variety. 0.7, maybe it's too much. Let's see. It's probably not diffusing enough, so we could add, I added more. Here we can increase the steps for final images. You could bump that to 40, for example. Okay, in this case it was too much. But hopefully you get the point that this is kind of an iterative process, and just keep testing out the different parameters. If you have any questions, just use a Discord chat or email me and so on. Okay, now I went too low. But hopefully the message is clear. All right, so the final step, which I'll cover very quickly, if this doesn't work and if you're not using the Pro version, which I do encourage you to get, open this other link at the top, Stable Diffusion Art. You can click on this link and essentially it's one cell. You just run the one cell, pick your models. If you want to add your models, it says model from URL. So add the 2 models with a comma, and just run it. It will download these. I like to use these other two if you want to test more models out. If not, you can exclude them. If you're patient, run it as it is. If you want to improve the speed, one thing I removed from the code, and you'll have to remove it on your end. Essentially, when it says I will download ControlNET, it's downloading a lot of different ControlNET models, which might just take too long and your runtime might go out. So just comment. All I did was left Canny and depth for Stable Diffusion XL, and I left the same Canny and depth for Stable Diffusion 1.5. So add this here, or you can do control / to comment things out. That's the only thing. So it says install ControlNet. That's where you'll find it. So if I double click back on the text, you can go back, and it runs in the same way. It uses this. It gives you a public URL. The only difference is that it asks you for a login, and at the very top, it just says what it is. Username A, password A. Login. It is the same user interface. Everything is the same. If you have any questions here or comments, definitely let me know. And there's your ControlNet right there. Cool. Have fun. Looking forward to seeing your work. Bye, guys.